Hello, welcome to ANS Solver. This is the third question of the paper. So it is claimed that on average, a number of particular train journey takes less than 1.9 hours. Okay, so they take a random sample of 50 days. Okay, and now we need to calculate the unbiased estimates of the mean and variance. So the unbiased estimate of the mean is simply summation of t over n. That means the unbiased estimate of my mean is 92.5 over 50. So when I solve this on the calci, I get my answer as 1.85. So this is the unbiased estimate of the mean. Now for unbiased estimate of the variance, the formula I use is 1 over n minus 1 with the summation of t square minus the summation of t the whole square over n. I know there are two formulas, but I stick with this formula because you can use any of the formula. There's no difference. You'll get the same answer. So here I get 1 over 50 minus 1 with the summation of t square, which is 175.25, minus the summation of t the whole square, which is 92.5 the whole square over n, which is 50. So now I get my s square basically as 0.0842 on the calci. So these are my unbiased estimate of the mean and variance. Now, test the claim at 5% significance level. So for this, I know my mean is 1.9 hours. Okay. I know the test value, which was the unbiased estimate of the mean, is 1.85. Okay. I know the variance, the population variance is 0.0842, which I calculated during the unbiased estimate of the variance. Okay, in part 1. And now I know my n is 50 because I took 50 days, the sample n. Okay. So now what I need to do is, I have my null hypothesis as the mean as 1.9. I have my alternate hypothesis, okay, which basically means the rival claim which states that this is less than, the time takes less than 1.9 hours. So I can say this is less than 1.9. So now I have my normal distribution curve something like this, correct? They are saying less than. So I know the z value of the significance level lies before the mean, and the value less than the z value is 0.05, which is basically the significance level, because 5% is 5 over 100, which is 0.05. So now I need to calculate the z value. So the value I have here is 0.95. Okay. So now what I need to do is, I'll go to my table. If you see here, the page 10 of your MF19, in the bottom there's critical values. Okay. Here if I see, the probability I have is 0.95 and the respective z value for that is 1.645. So I can write here 1.645, but because this is less than, we determined it's less than the mean, so I write a minus. Now I need to calculate my z statistic value, which is basically the value, the test value minus the mean over the standard deviation over root n. So basically I can write this as z star equals to, I know my value is 1.85 minus 1.9 over 0.0842 over, and the square root of this, because this was the variance, so the standard deviation is the square root of variance, over the square root of the number of samples. So I can now solve this on the calci. It'll take a little time, but I'll know I'll get the correct answer. So when I solve this on the calci, I get negative of 1.218. or negative, my z star basically I get as negative 1.22. So now I compare basically the mod of z star with the mod of the z value. Okay, so now I get the mod of 1.645 and the mod of 1.22. Got it? So I get this as 1.645 and 1.22. Now you tell me which one is bigger. Okay, actually I wrote it the other way around. The mod of the z star value is basically the mod of 1.22 and the mod of z is the mod of negative 1.645. My bad. So I get 1.22 here and 1.645 here. Now I know my z value is bigger. That means I do not reject my null hypothesis. Okay, why? Think about it graphically. I know the negative 1.22 lies somewhere here. Okay, and I know my critical region is below or less than minus 1.645. So minus 1.22 does not lie in the critical region. So that means I can say that there is no evidence of a decrease in average time. Okay, this is what I can claim.